Hello, today we're going to talk about nuclear energy. Alright, today we're going to talk about fusion and fission. The first one we're going to talk about is fusion. So the technical definition of fusion is the joining of two small nuclei to form one nucleus with a larger mass of the original nuclei. So it's the joining of two nuclei together. So coming together is fusion, fission is breaking apart. Alright, so this releases a tremendous amount of energy when fusion happens. It's actually 1 gram of fused hydrogen releases up to 20 tons of coal when burned. That's a lot. Fusion is also good because it's a non-pollutant. It releases no radioactive daughter element. Fusion is also used in the hydrogen bomb. But fusion only happens under tremendous pressure and heat, and that's only in like the core of stars. So there you go. An example of fusion is the sun produces enormous amounts of heat, light, and other forms of energy through fusion reactions. That's fusion. Alright, so we talked about fusion, now we're going to talk about fission. If fusion is the joining of two nuclei together, fission is the breaking apart. The actual definition is the natural or artificial breaking up of atoms into smaller pieces. So when we split atoms, you extract energy in nuclear power plants. Alright, so in 1932, scientists at Cambridge figured this out. They were trying to speed up an alpha particle fast enough to shoot it at a lithium atom, and they thought it would join with the nucleus and become larger. What it did instead is it actually split the lithium atom into two. So that's fission. It splits it into two different atoms. Then they went on, this is just something, this helped prove Einstein's E equals mc squared. Somehow, I don't really know because I am not that smart. I did read it, but it's a bunch of stuff. I was tired and I didn't quite get it, but you don't need it for this lesson. So nuclear energy is released induced by splitting atoms, fission, radioactive decay. So nuclear energy is induced by splitting atoms, fusion, and radioactive decay. Now here's this other thing right here. Here's an equation, and here's all the answers to it. That's in the lesson. It's not something you have to know, so I just filled in all the answers for you. But this is a fission reaction. So you have your uranium? Yeah, so this is it. So you have one neutron over here, and here you have 3 neutrons that it emits. There you go, there's a bunch of stuff for you, you can just write it down. When you get to that part, because again, this is for our lessons, so I'm only giving you information you actually need and not random stuff. Alright, we're going to burn through these last sections pretty quickly. So nuclear power plants. Power plants produce energy by process of nuclear fission. We already talked about that. There's parts of the power plant. There's the shield, which is the concrete and lead enclosure. There's the control rods that absorb emitted neutrons. Nuclear fuel is the mass of unstable atoms. The coolant, energy transfer medium, and the moderator slows down neutrons. These are components of a nuclear reactor. So shield, control rods, nuclear fuel, coolant, and moderator. Major problems with the production of nuclear energy is it's harmful to animal and plant life, potential reactor accidents, hazardous solid waste. You guys remember it was in Japan or China, that tsunami? I believe it was Japan. the tsunami hit that nuclear reactor, and they were in there trying to keep it from burning all the way down. Nuclear reactors are very, very dangerous if they're not watched very well. The big problem with it is the waste that comes from it. So there's also research and technology. So uses of nuclear chemistry and sterilizing equipment, pasteurizing farms, thickness gauges, tracers, leak detectors, sterilize bacteria and viruses so they can't reproduce, and nuclear medicine, common use of radioactive elements in healthcare, soft tissue images, diagnosis of disease, treatment of cancer. And there you go. All right, this has been nuclear energy. The basic, the thing that you need to get out of it. Fusion is joining together, fission is breaking apart.